My name is Amira and I will continue with question number 1. Compound interest is a simple interest on interest, unlike simple interest, which only pays you based on your original money. Compound interest is calculated on both your initial balance and the accumulation interest from previous periods. This creates a snowball effect that accelerates well over time. This means that the interest earned is added to principal, allowing the investment to grow at an increasing rate over time. As a result, compound interest helps saving and investment grow faster compared to a simple interest, making it an important concept in personal finance and investment planning. This makes compound interest more powerful than simple interest, which is calculated only on the original principal. Compound interest plays a significant role in savings, accounts, investments, loans, and other financial products because can greatly increase in the value of an investment over a long period. The longer the money remains investment and the more frequently the interest is compound, the greater the overall growth will be. Therefore, understanding compound interest is essential for making informed financial decisions and planning for future financial goals. This compound interest has a formula which is A equals to P brackets 1 plus R over N brackets source of power. All of this formula has a meanings where A equals to final amounts, P equals to principal amounts, R is annual interest rate, N is a number of time interest is compound per year, and T is time in years.
We are given an initial principal amount P of 10,000 ringgit, which grows to a future values as of 12,300 ringgit over a period T of 2 years. The interest in compound bi-monthly, meaning 6 times a year, means M is 6. Our first goal is to find the nominal annual interest rate, which is K. So this is a formula. We must use this formula to find the answer. We must fill one by one by using the formula. Next, we isolate the compound interest term by dividing both sides by 10,000. This gives us a growth factor of 1.23 on the left side. To undo the power of 12, we take the 12 roots of both sides. The 12 roots of 1.23 give us approximately 1.0174. We subtract 1 from both sides to get 0.0174, which represent the interest rate per compounding period. Finally, we multiply by 6 to convert it back to an annually nominal rate. This gives us a decimal of 0.1044 or an annually interest rate of 10.44%. Moving on the second part, we take the annually interest rate we just found 10.44% and apply it to a new scenario. Here, the accumulated amount from the first investment is reduced by a withdrawal of 500 ringgit. This leaves us with a new starting principal P of 11,800 ringgit. We must use the formula for part of 2. We use the same compound interest formula to see how this new amount grows over a new period of 4 years. The interest rate remains 10.44% and it is still compounded 6 times a year. This gives us a total of 24 compounding periods, which is 6 times 4. After calculating the growth over those 4 years, the final maturity values come out to 70,845 ringgit 33 cents.
Alright, for question 3, I will explain annuity. An annuity is a series of equal payments or deposits made regularly over a certain period of time. The payment amount remains the same throughout the annuity period, and payments are usually made at the end of each period. Annuities are commonly used in daily life for loan repayments, insurance premiums, rent payments, and installment plans. They help individuals and businesses manage their cash flow more effectively. Next, this is the formula for the future value of an annuity. This formula is used to calculate the total accumulated value of regular payments, including the interest earned over time. S equals the future value, R equals the regular periodic payment, I equals the interest rate period, and N equals the number of payments. Lastly, the formula for interest earned is I equals S minus Rn. In this formula, I represents the interest earned, S represent the future value, and Rn represent the total amount deposited. The formula calculates the total interest earned by subtracting the total amount deposited from the future value.
For question 4, given that M equal 12, R equal 250, I equal 6 divided by 100 divided by 12, which is equal to 0.005, and N equal 12 times 5.5, which is equal to 66. Next, I use the future value annuity formula, substituting the value as 66 equal 250 multiplied by open bracket 1 plus 0.005 close bracket raised to the power of 66 minus 1 divided by 0.05 close bracket. As 66 equal 250. For the last question 5, question number 1, I use the present value of annuity formula to find the monthly payment R. The amount needed is 170,000. The annual interest rate is 3.5% and the loan period is 20 years. First, I convert the annual interest rate into a monthly interest rate by dividing 3.5% by 12. Then I substitute all the value into the formula. After calculating, I get R equal 985.93 cents. Next, question number 2. I use the future value of annuity formula to determine the accumulated amount after 4 years. I substitute R equal 985.93 cents, the monthly interest rate of 3.5% divided by 12 and equal 4 years. After performing the calculation, the value of S is 3,961. Therefore, the accumulated amount after 4 years is 390.61.